everybody, it's Mike and Sean again with the Good Math Guys. In this video, we're going to be discussing how to simplify fractions using prime numbers. I know fractions are an area of concern for a lot of students and a lot of parents, and a lot of headaches and lost sleep and tears and arguments happen because of fractions. We're here to try to make your lives a little bit easier. A couple prerequisites that you need to be good at and be aware of before watching this video are: number one, you need to know what prime numbers are. Number two, you need to know what composite numbers are. And third, and most importantly, you need to know how to construct a prime factor tree. In the video, the presenter has 3 examples, and for each example, you're going to see him construct prime factor trees. If it takes you 3 or 4 times watching the video before you can master that skill, please do it, because it will make understanding this strategy all that much more easy. Also, if you note on the side of our video here, we have some written notes. I recommend watching the video first, reading the notes, and then maybe even watching the video again. Whatever you need to do to become comfortable with this strategy, we highly recommend you do it, because it is a very, very great method. Keeps everything organized and simple right there in front of you. So without anything else, let's get into the video.
Today we're going to do the second video on simplifying fractions. In the first one, what we did was used regular factorization and composite numbers to arrive at the GCF, and then show you how you could use the table in order to simplify the fraction. Today what we're going to do is focus specifically on prime numbers to find a GCF and then also find the fraction in simplest form. So it's very important, and all 5th graders at this time of the year should have an understanding of what a prime number is. It's very important that they do, and that they know that by definition a prime number is a number that has exactly, and that word exactly is very important, exactly 2 factors. If it has more than 2, it's going to be composite. So if I were, for example, to take the number 7 from the list of numbers here that are prime, and we factored 7, we'd start with the identity property, which is 1 times 7, so that if there were any other factors within this range, they would show up. In other words, if 2, 3, 4, 5, or 6 could divide evenly into 7, we'd have to include those in here. But obviously, 7 is not divisible by any one of those digits. Therefore, it has exactly 2 factors and would be considered prime. Now, prime numbers are unique because all positive whole numbers can be factored into a product of prime numbers. Then we can use that to simplify fractions. So let's take a look at how that works. I'm going to flip over to something that we call a Venn diagram. Now, the Venn diagram consists here of 2 circles that we'll call sets. So we have the set for n, which stands for numerator. We have the set for d, which stands for denominator. And we have this area in here that we call a union of both of those sets because they overlap. And what we're going to do is we're going to plug anything that's unique for the numerator and unique for the denominator into the union of both sets, and then the rest will belong either to the numerator or the denominator only. So let's take a look at a fraction that we might want to simplify. How about, for example, 12/18? Now, what we're going to do is we're going to go over here and we're going to create a factor tree for 12, and we're going to create a factor tree for 18. And unlike what we did in the first video, what we're going to do here is factor these numbers using only prime numbers. Now, there's a couple of ways we could start here. We could start 2 times 6, or we could start 3 times 4. It does not make any difference. So let's start our tree with 2 times 6. Now, we know 2 is a prime number. So what we're going to do is bring that down, and then we're going to factor the 6 because we know 6 is composite. So factoring 6, I can go with 2 times 3. So the prime factors of 12 would be 2 times 2 times 3. Let's go over and do the same thing for the 18. So starting the factor tree, we can go 2 times 9. We can go any of the 2 composite partners that you want to start it off. 18 is an even number, so I like starting with 2. So we'll go 2 times 9. 2 is definitely prime, so we're going to bring it down. 9 is composite because 1, 3, and 9. So we've got more than 3 factors there, so we have to factor the 9. So let's extend our tree to 3 times 3. So the prime factors of 18 would be 2 times 3 times 3. Now, here's what we're going to do. We're going to take these factors and we're going to plug them into our Venn diagram. And remember, I said now factors that are unique for both go into the union of both of these sets, and factors that are not unique of both go into their specific areas. Okay, so let's do that. I see a 2 right here, and I see a 2 right here, so that's a shared factor. It's going to go in the center. I see a 3 right here, and I see a 3 right here, so that 3 is a shared factor. I see a 2 right here, but I don't see another 2 over here, so that 2 belongs to the set for n only, the numerator only. I see a 3 over here, but I don't see another 3 over here, so that 3 belongs to the set for denominator only. Now here's how we use this information to find GCF and the simplest form. To find the GCF, all we have to do is multiply the common factors in the union of both sets. So we've got 2 factors here. 2 times 3 is 6. So 6 would be our GCF. Real easy. To find our fraction in simplest form, all we're going to do is take what's left in the numerator's position and what's left in the denominator's position and write numerator over denominator. So here you'll notice we have a 2. Here you notice we have a 3. So 12/18 simplifies to 2/3. Real easy, real easy. Let's try another one. We're actually going to try 2 more here. Let's do 24/30. 24/30. Okay, 24 is the numerator. 30 is the denominator. So let's start our factor tree with the 24. Again, even numbers here, I like to start with 2, but if somebody wants to start with 4 times 6 or 3 times 8, that's fine. Let's actually start with 3 times 8. We know that 3 is prime, so we're going to bring it down. We know that 8 is composite, so we're going to factor it to 2 times 4. Three is prime, so we continue to bring it down. 2 is prime, so it comes down. And the 4 factors to 2 times 2. So our prime factors of 24 are 3 times 2 times 2 times 2. 3 times 2 to the 3rd power. And 5th graders should be into that kind of stuff right now too. So let's factor the 30. Let's go with, how about 3 times 10? Students have a choice here. They could have gone 2 times 15, but we'll start with 3 times 10. 3 is prime, so we'll slide it down. 10 factors to 2 times 5. So 3, 2, 5, all prime, we're done. Okay, so now what we're going to do is play this game where we try to figure out what's unique to both, what's unique individually. So over here I see a 2, I see a 2 over here. So let's cross out that 2, and let's cross out this 2, and that 2 goes in the middle. Okay, I see a 3 here, and I see a 3 over here. So that 3 goes in the middle. Over here I see a 5. I do not see a 5 over here, so that was unique to the denominator only. And over here I see 2 more 2's, and I don't see any more 2's over here. So these 2 2's are unique only to the numerator. All right, now let's see if we can find our greatest common factor. Again, the product of both numbers or all of the numbers that are in the common area. So in this case, that's 2 times 3 is 6. So we're going to say the GCF is once again a 6. All right, fraction reduced or simplified. Only thing left for denominator is 5. Over here we've got 2 2's, so it's the product of these 2 2's, so we're going to multiply them together. 2 times 2 is 4. Therefore, 24/30 simplifies to 4/5. Pretty cool. And the kids love drawing the Venn diagram, so this is a cool method for them to learn. Let's try one more before we quit. How about 33/36? 33/36. Okay, and we know the 33 belongs over here. And the 36 belongs over here. And what we're going to do is factor both. So here, 3 times 11. We know that if kids are up on the first few prime numbers, 2, 3, 5, 7, and 11, they know that both of these numbers are prime, therefore we're done. Over here on the 36, we can start with, if we want to, 3 times 12, which is 36. 3 is prime, so it comes down. We factor the 12 to 3 times 4. Both of these 3's are prime, so they come down. And we factor the 4 to 2 times 2. Now we have all primes, 3's, 2's, both primes. So we're all prime here, so we're finished. All right, now all we have to do is stick in the middle what belongs in the middle. So I see a 3 right here, and I see a 3 right here. 3 goes in the middle. I do not see an 11 over here for the 36, so 11 is unique only to the numerator. I don't see any more 3's or 2's over here, so for the denominator, unique to the denominator only is 3 times 2 times 2. All right, so in this case, the GCF would be 3. There's nothing to multiply it to. And the fraction in simplest form, obviously here, this is easy. For the numerator, it's going to be an 11, and the denominator is going to be the product of these 3 numbers. So 2 times 2 is 4, times 3 is 12, so our denominator is 12, and that fraction simplifies to 11/12. Again, the kids really love this. They enjoy doing the Venn diagrams, believe it or not, and that's something that 5th graders should know about. So we hope you enjoyed this, and we hope you can easily see the difference between regular factorization table like we did in the first program and a prime factorization trees that we did here in this episode. For now, there's nothing else, so it's the Good Maths guys saying until next time, bye-bye.